All right. The final type of graph is scatter plot. These are the most complex because they have two different sets of numerical data that you want to compare. And you really need to understand what your data is showing and whether you want to show only the average data of your trials or all of them. So here's an example experiment. We've got some laboratory rats where scientists have fed them different amounts of food over 3 weeks, different amounts of food per day. All the food amounts were within the healthy range, so there were no ethical issues with this experiment. So they've given rats 35 all the way up to 50 grams of food. And for each amount of food, they had 3 different individual rats. So they were called our first, second, and third subjects. So every single one of these data points, these 18 points here, they're all completely separate rats. And so they're not connected in any way. We're not looking at change over time. So it's not a line graph. You want to be thinking straight away. We've got food, which is numerical data, and then the running speed that the rats could run at as our other set of numerical data. Obviously, the pattern should be the more food they were given, the more quickly they could run. So let's see if that fits our data. All right. So in this case, we've got 3 separate rats. We can average out their running speed, but the good thing about a scatter plot is it can easily show all of our trials in one graph because they're only a single coordinate on the graph for each subject. So we actually do want to include the food per day and every one of our different 18 rats, sample rats. So we'll highlight all of that data, insert charts, and we're choosing scatter plot. Okay. So Excel was smart enough here to recognize that that first column is our horizontal axis. That's our independent variable. We do have 3 separate series, but you don't need to color coordinate them in this experiment because the first, the second, and the third subject, they were completely separate rats. They were just the number they were assigned in the experiment. So that means we don't need to have separate colors either, which we'll get to. All right, this is mostly finished. We only have to get rid of our lines in between. Scientific graphs are much easier to read if you don't have those vertical and horizontal lines. We don't need a chart title. We do need to have labels on our axes. We also want to have our tags, our tick marks. So let's format the axis. Go down to tick marks. Add them on the outside and do the same for the horizontal axis. Major tick marks on the outside. Here we can probably add in minor tick marks because halfway between counting by tens makes it easier to read. So we'll add in tick marks on the outside. We don't need 5, so we're going to go up to the units that we're counting by on this axis. So the major units we're counting by tens, that's reasonable. The minor axis, well, let's count by 5s. So the minor tick marks are now going to count by 5s. All right, so we had food per day. The rats were fed. Then we have their running speed in meters per second. And we basically have the scatter plot. Like I said, we don't need separate colors. So what we can do is edit each one of these data series separately. So right click on the orange data series, go to the paint bucket, and we'll go to marker, which is the actual dots. And you can see here they're colored orange. So let's make all of our markers black. The green ones, format. Black. So I didn't change the border. They have a border as well. So we'll change the border to black. We'll do the same for the orange ones. And these last green ones, change the border and the fill. And now we have a nice, clear scatter plot. And so the whole point of a scatter plot is to be able to draw a line of best fit, which is called a trend line. And that will help us to see the trend. And you can actually calculate the formula for that trend line, which is a linear equation most of the time. And you can use that to make predictions and extrapolate your data to predict rats who were fed less or more than 60, or to predict some other rats if you were going to test in a different experiment. Okay, so here's our caption. We'll add that in. Figure 1. And the final thing is to actually add in the trend line. And that's one of our chart elements up here. So we'll click on the plus, add in a trend line. And it asks us, it can only do a trend line for each single series. So we're actually going to add in the average as well. So these are here. So the blue is the average of all of our data. And now if we add in the trend line, we can click series 4, and it's putting a nice line of best fit, which best matches the scatter plot data here. We don't really want to show our actual average coordinates though, because they don't exist as real data from our rat experiment. So we'll go to format and we'll make those white so you can't see them. Fill white and line white. Okay, there's a nice clear scatter plot where we can easily see the overall trend, which will be easy to write in our discussion and discuss now, where the number or the amount of food given per day causes the running speed of rats to increase over time. All right, so choosing and selecting your best type of graph is the main consideration firstly when you're looking to show your results, and you're thinking about which types of data are we using, and we're thinking about how do we actually want our data to be shown. Do we want to show it as a story? Do we want to show individual data points? And then that helps guide us to which graph to choose. And the whole point where graphing data is to show it visually and make it easier to interpret and discuss and make conclusions from.